purpose behind this video is to show users how to generate break lines around islands using LP360. The first task in digitizing break lines is to set up your conflation tasks. This is done on the LP360 Digitize Break Lines toolbar in the Conflate Tasks Manager. We will need two tasks for this. The first one is our main water bodies where our islands reside. The geometry type for the feature class is going to be a polygon. We're going to use the summarize Z conflation method, and we're going to compute one elevation value for the feature as a whole, and that information is going to get stored in the attribute table. In this instance, we're looking for the lowest elevation value, so we're going to choose a minimum Z, and we're going to be looking within 10 map units of any given LiDAR data. We're going to use an H-type field to help us distinguish between different features within the feature class. And in this instance, we will call this a lake. Our second task is going to be the conflation task for our islands. Again, this is going to be a polygon feature class, and we are going to use the summarize Z option. This time we are going to store the information in the vertices, and we're going to have one value for all the vertices. The H-type field will be used again. This time it will be called islands. After defining our conflation tasks, the next step is to create a blank shapefile that will be used for the digitization. This can be done multiple ways. In this instance, it is going to be done through ArcCatalog. Make sure to enable the shapefile for 3D, and you can add a coordinate system to it if you choose. Prior to starting any sort of digitization, make sure that the two fields defined in your conflation tasks have been added. Your first field is a text field, and we called it H-type. And this is going to be for our island and our lake classification. The second field is for our elevation value for our lake. Once the attribute fields have been added to the attribute table, an editing session can be started. Select your active conflate task. We are going to start with the main water body. And then select the LP360 sketch tool. If your profile window is not already active, select the P key on your keyboard and begin digitizing. Notice that the main water body is digitized in the clockwise direction. Once the feature is complete, open the attribute table and take a look at the elevation value that was determined. In this instance, we are looking at a minimum Z value of 122.619. This is the same value that we want to assign to our islands. Under your active conflate tasks, change to island and use the LP360 sketch tool. Select the L key on your keyboard to activate locks. We want all of the vertices on this island to have the same elevation value as our lake, and so we're going to have H set as a constant. We are going to put one vertex down. We're going to right click on it and we're going to set a Z-lock height. In this instance, that is the same value that we want as our lake, so 122.619, and this is going to be the value that will get assigned to all the vertices. Continue digitizing in a counterclockwise direction. Once the feature has been completed, the next step is to reclassify any ground points that currently exist within the break lines. This is going to be accomplished creating a macro within the point cloud tasks. There will be 3 steps to this. The first task is going to classify any ground that exists within the lakes. This is going to use the existing shape layer we just created. Our source points are going to be ground only. We're going to select our H-type field as we do not wish to reclassify the islands. We just want to reclassify within the lakes. This is going to be completely within, and we're going to put this on class 9. The second task that we're going to add is going to reclassify any water from within the islands back to ground. In this instance, we want to reclassify any of the water back to our ground class. Again, we're going to use H-type, and we're just going to use our islands. And this will go back to ground. Our last task is going to classify around our break lines into a break line proximity class as defined by the USGS. The source points for this are ground points that have been buffered. And this is going to occur within an approximate distance equal to our nominal pulse spacing. And the new USGS LiDAR specifications says this needs to go on class 12, which is currently set as reserved. Once your macro is set up, you can run it for your project. At this point, you should now have reclassified your data, and brake line enforcement can be activated. We're going to use the type field to specify the elevation field that will be used for each type feature. The lake is going to use the minimum elevation value stored in the attribute table, while the island is going to use the information stored in the vertices. We are going to remove water and our reserved class that we set as our buffered ground. And at this point, we have generated brake lines around our islands.